shoulder joint age estimation. Now, the motive of this video is to just somehow pass the practicals. Okay. So in university practicals, the professors, they expect basic points and basic understanding of what's happening around. Okay, so I'll be just giving you some jugadu concepts or make sure we pass. So this is the entire note for today's discussion. Okay, right. So if you're looking for something like very in-depth knowledge of about all these things, how it is working, x-rays and all, then maybe this video is not appropriate for you. Okay, because I'll be sharing very superficial details, because even I don't know how, like, I'm not the expert in understanding the x-rays and all. I can just know, okay, this is the humerus, this is the head of the humerus, this is the clavicle, the acromion process, okay, the scapula is here, okay, glenoid cavity. So I just know the basic things. So if you're looking for something very in-depth, maybe this video is not for you, right? So moving into the concepts or moving into the video. So age estimation from ossification of the bones. Now, first of all, why are we doing this age estimation? Why is it necessary? Let's say some crime has happened, and if you're not sure whether the person is younger or elder, like if he is below 18 or above 18, so is there any way that we can know? Yeah, that is this way. Okay, this is a very simple, non-invasive way, taking x-rays and trying to identify the chronological age of that person. Now in India, every time something keeps happening around the country. Okay, like recently we had a case of some rich kids driving Porsche and killing few people. Okay, at the end they had to just write an essay and that's all. I don't know how that works, but anyways, so to understand the age of a person, or for the legal and criminal investigations, like as I said, juvenile justice, or in case of rape, POXO Act, then there can be disasters like in mass disasters, war zone, or if there is any bomb blast or plane crash. So to identify the age of that particular group of people, okay, so there also it can be used. Not just the x-rays, the physical bones can be used, the x-rays of dentation can be used. Okay, and x-ray is a non-invasive method, right? So this is a good way, this is a better way. So here what it is written, let's see. For age estimation, plain x-rays of long bones and pelvis are taken and examined for appearance for the primary and secondary centers of ossification. So if I tell about the ossification center is nothing but these are certain places or centers where the bone formation begins. Now it can be two types, one as it is given here, one is primary, the other one is secondary. So the primary means the first time or the first area where the bone is forming from. Where bone is forming from the framework of the cartilage. So there is cartilage, inside that it's like a mesh of cartilage where the calcium is coming and it is getting deposited, right? And after the deposition of those calcium particles, calcium ions, these framework of the cartilage slowly gets harder, right? So the primary centers, they appear during the fetal life, and mostly it is in the a shaft, or if I'm talking about the long bones. Now secondary centers means, so after the initial bone formation, whatever the things are left to get ossified after the birth, maybe, or maybe after many years, so that is the secondary centers of the ossification, and then their fusion. So we are examining the appearance of the primary and secondary centers of ossification and their fusion. Usually, now this is just fact, usually there are some 806 ossification center in 11th intrauterine week. So at this point there are some 806 ossification centers. Then at birth it becomes 450, almost like half or reduced. Okay, all these centers fuse with their respective centers to form 206 bones at the time of the adulthood. At the end we have the 206 bones. Okay, that we understood. Now this is important, this is what our teachers will ask us, and if we know this much, it will be enough. Even if you cannot exactly tell the age of the x-ray, it is okay, but we have to know this by heart, like at what age what happens. So in the shoulder joint, as we are reading about the shoulder joint, so head of the humerus, greater tubercle, lesser tubercle, and acromion process. So this is what it is given in our record. Okay, so this is the picture. So this is the picture, as you already know this. So this is what, this is the clavicle, this is what the acromion process, this is coming from where, this is coming from the this scapula, this is the coracoid process, and this is the humerus, this is the head of the humerus, and this is the greater tubercle and the lesser tubercle. So this is how it is normally, like gross picture. Okay, in x-ray how will this look? In x-ray this looks something like this. So this is the clavicle, this is the humeral head, this is the coracoid process, this is the acromion process, and this is the lateral border of the scapula. Okay, so you can see one more x-ray here. This is the normal x-ray, right? This is the acromion process. Here you can see the glenoid cavity, this is the head of the humerus, and this is the shaft, this is the greater tubercle, this is the lesser tubercle, and this is the shoulder blade, that is nothing but the scapula, right? So we have seen the anatomy. Now let's talk about the age of appearance and age of fusion. Now what do we mean by age of appearance and age of estimation and age of fusion? Now as we know, appearance means what? Appearance means, as I told, the primary center where the bone formation begins. Okay, so that is nothing but the appearance, the centers. So this means that the bone starts forming in a specific area, and it is visible in the x-ray like small rounded radiodens. Now I'll show you here. See, here you can see. So this is an x-ray of a 2-year-old. Okay, this is just a 2-year-old baby. As you can see here, this is the humerus. Can you see the head of the humerus, that ball part? Can you see? No, you cannot see. What can you see? You can see there is some round thing here, there is some round thing here, and nothing is fused. You can see there is a good amount of gap, everything. Nothing is mature, nothing is fused yet. So these round radiodens, okay, although it is not looking radiodens, but okay, it's fine. So these are the ossification centers. Okay, you cannot see greater tubercle, you cannot see lesser tubercle here, right? But now if you just check this 7-year-old kid, now can you see something here? You can see that the head of the humerus, you can see, right? But here, can you see this is not fused? See, you can see that there is clear demarcation here, right? But as if you see this one, can you see any demarcation? This is all smooth, this is very nicely fused. So this is an adult, proper adult. See, everything is looking very nicely here, all the matured bone, okay, and nicely fusioned bone. Okay, adult shoulder joint. Now we don't yet know the age of this, that will look, but I'm just showing you how it looks. Okay, so these are the ossification centers. Now let's go to the age estimation. So shoulder joint, we know the head of the humerus, the age of appearance is 6 months to 1 year. So if you can see the head of the humerus, then most probably the child is around 6 months or maybe 1 year of age. So here, as you can see here, the 2-year-old kid. So slowly you can see that there is some formation of the head of the humerus. You can see here, it is forming, right? It is not properly seen here, but okay, it is. See here, it is there is a little curve here, right? So it is forming, it is at that stage. In the 7-year-old, you can properly see it is well formed head of the humerus, but although it is not fused. So we'll read here. See, now let's talk about the greater tubercle and lesser tubercle. Now greater tubercle, it appears around 3 years of age, and lesser tubercle appears at the 5 years of age. And then the acromion process, it appears around 14 to 15 years of age, right? And what about the fusion, the age of fusion? Now all these three, the head of the humerus, greater tubercle, lesser tubercle, all this fused together, the head of the humerus, that is called as the conjoint epiphysis, that is 5 years of age. So if you can see all these three things are properly fused, then you can automatically understand this is a 5-year-old, approximately 5-year-old kid, right? Then if you can see that age of the fusion, like the acromion process is fused with the clavicle and the part, okay, so he or she is almost around 17 to 18 years of age, right? So we'll see here. So here we saw that there is no greater tubercle, there is no lesser tubercle, because the greater tubercle or lesser tubercle, when does it comes into picture? The greater tubercle, it takes around 3 years of time, the lesser tubercle, it takes around 5 years of time. So this kid is just 2 years old, so we are not able to see. What about this kid? This kid is 7 years old. So here you cannot exactly properly see, but still, if there is head, there must be greater tubercle this side and lesser tubercle this side. So I'll just show you on one more picture here. Okay, here you can see this is the greater tubercle and this is the lesser tubercle. Okay, so this person is more than 5 years of age, that we surely know now. As you can see, there is no demarcation here, so this is also fused. So and all these things are also properly fused and formed, and it is visible. So all this together, as you can see here, so age of the fusion is 17 to 18 years. So this picture is at least, like by looking at only this picture, this person is at least somewhere around or more than 17 or 18 years of age. Now see, the thing is, by looking at one picture we cannot exactly pinpoint okay, this can be the age or this is the age. No, we cannot do that. We need multiple pictures, like not just the shoulder joint, we can use the pelvic also, we can use the dental picture, we can use the elbow. Okay, so if there are multiple pictures, then we can come to a conclusion or estimate properly, right? So by looking at only one picture from one point of view, it is little not so accurate. Okay, so we understood some basic things of the X-ray. Now this is exclusively for my friends. If you are watching this video by any chance, so when you will open the PDF of X-ray, you will get the first case as Gayatri. There are two cases of Gayatri. One is 16 years of age, the first one, and the one is I guess 17 years of age. Okay, then you will find one girl with the name Rashmi. She is 11 years old and she is the smallest one, like age wise. And there is one guy, Sundar Raj, who is 28 years, the maximum age in that PDF. So let's talk about this. Okay, how can we try to estimate the age? By looking at this X-rays. Okay, so as you can see here, now talking about this picture, so as soon as I see this picture, first of all my eyes will go to this part. Okay, now here as you can see, this is the greater tubercle, this is the lesser tubercle, this side. So when I am looking at this picture, I will try to, or my eyes will try to find the point which has the highest relation, because if that point is there or if that thing is true, then the other points must be already done. Like what I'm trying to say is, let's suppose if I can see the lesser tubercle here, so lesser tubercle is, that means the appearance of the lesser tubercle happens when 5 years of age. That automatically means that the greater tubercle will also be there, so that is 3 years of age. So then I automatically understand okay, this person must be more than 5 years of age. So then I will not think about the greater tubercle where this present. It is known that it is already present. Okay, so that is there. Now as you can see that there is little depression here and there is a line here. Okay, that means somewhere it is in between the fusion, somewhere the head and all this epiphysis. What is that? The conjoint epiphysis. What is conjoint epiphysis? The head of the humerus, the greater tubercle and lesser tubercle, all this when fuses together, so that is the conjoint epiphysis. And if it is there, then that is understood he is 5 years of age, at least 5 years of age. So we can understand by this only that this is 5 years of age. Now what did they say here? That age of fusion, the conjoint epiphysis fuses with the shaft. So you can see here this conjoint epiphysis, this is fusing with the shaft. What is this? Is the shaft. So you cannot see any clear demarcation like you saw here. There is a good demarcation, okay, here, but you cannot see. This is smooth, so that means it is fused. So can we tell that this is around 18 to 19 years of age? Yes, we can approximately say that this is 18 to 19 years of age, but this is not the accurate, right? Now to understand little bit more, what can we see? We can see that the coracoid process is also properly visible, then the acromion is visible properly. So if we can see the acromion process nicely, okay, like distinctively, then we can say, sir, I can see the acromion process properly, so this boy or girl maybe around 15 to 16 years of age. Now they said in the theory, in that practical record, that fusion of the acromion process, it is around 17 to 18 years of age. Now I could not understand this, where, like what fusion he is talking about, whether the fusion with the clavicle or what, because acromion process is somehow related closely proximity to the clavicle. So I'm not sure about that fusion, but if you know anything about that, you can just let me know in the comment section. Okay, so that's how it is. So we can approximately tell that this person is more than 5 years of age, more than or at least equal to 15 to 16 years of age. Now, is there anything here that we can come to a range? So here you can see one more thing, that this is the clavicle, this is the medial head or medial side of the clavicle. Here you can see a clear cut demarcation, right? If I can zoom in here, you can see that there is little gap kind of. So the medial part of the clavicle, medial head of the clavicle, this fuses when this fuses at more than 22 years of age. Okay, and we know already ki this clavicle is a horizontal. Like, what are the peculiar features of the clavicle? First of all, this is a horizontal bone, then there are two ossification centers, and this is the bone which ossifies, matlab it starts to ossify at the first, but it is the bone which ossifies at the last. So all these basic things we know. So here you can see this part is not yet ossified. So if it is ossified, then we can tell, okay, this person is more than 22 years of age or more than 20 years of age approximately. But we can say that this person is not more than 22 years of age. So we could come to a conclusion ki maybe this person is somewhere in between 16 to 20 age, because in order to estimate accurate we need multiple pictures. As I said, we need multiple sites ka x-ray, like the dentation, the skull, the pelvis, the elbow. Okay, so if there are multiple references of the same person, then we can come to the accuracy increases, right? So we can just say almost ki this person ranges from this to this. Okay, so by looking at this, we could understand ki somewhere this person is between 18 or 19 years of age. But is it so? Because in the X-ray, it is given as Gayatri, like her name is Gayatri and her age is as 16. So we are not accurate here, because the age is given 16, but to our finding, it is somewhere around 18 years or 19 years. Okay, so that's what I'm trying to say. Ki here we cannot exactly say, okay, this will be her age. Then let's talk about the Rashmi, who is 11 years of age. She is the smallest in the PDF. So here, as soon as you can see here, you can see that there is a good clear cut demarcation here. So that means this is not fused. That means she is definitely not 18, 19 years old. She is below that. Okay. So what else can you see? Can you see the greater tubercle? Yes. That means she is obviously she is more than 3 years. You can see the smaller tubercle also. So she is more than 5 years of age. So we got a range here 5 to let's say 18. So you still with just this bone we could understand that. Anything else can we see? We can see the acromion process. Acromion process is seen when acromion process is seen somewhere around 14 years of age or 15 years of age. It is given here. So she is somewhere around 14-15 years of age maybe. Okay. Then although it is not clearly looking the medial side, but yeah, okay, so we understood ki she is not more than 18 years of age and she is somewhere around 14-15 years of age. So I don't know how to interpret more in this, but yeah, the age given is 11 years of age. So we can give a range. I think she must be around 14 to 15 years of age. Okay, if you know any better way to understand this picture, you can please help me out. Okay. Then what else here? I wanted to show you this one, Sundar Raj, who is 28 years of age. So what can we see here? So see, you can easily see here that this is very smooth here. All the bones are properly fused. There is no mark here. There is no demarcation points. So we can 100% say this is more than 18-19 years of age. So so yeah, from this part only we can say this person is more than 18 or 19. Then anything else can we see? We can see good prominent acromion process. So definitely it is more than that, 18, 19 or 18, the 11, 12 years of range that crossed. Okay. Then here if you come to the medial part of the clavicle, here can you see any demarcation? Like you could see here, like there was a thin demarcation here, right? Can you see anything here? It is all smooth, so it is all fused. So by this I can say that this person is more than 22 years of age. Alright. So by this I can say this person is more than 22 years of age. Now is this accurate? No, because the given age is 28. So as I said, only looking at this one plane of the XA, one part, one shoulder joint, we can just estimate like to a little extent, but not accuracy will be very low. So we need multiple pictures, multiple x-rays of the same person in order to get a accurate or more proper value. You're getting my point? So yeah, we just need some idea, basic idea. Yeah, we can tell our teachers, our professors, sir, yes, this is how it is. So we need some general idea about that. But the thing is, we have to mug up these things. Head of the humerus is 6 months to 1 year. Okay, the greater tubercle is seen in 3 years, lesser tubercle in 5 years, Ackermann process in 14 to 15 years, and all these three together, the head of the humerus, greater tubercle, lesser tubercle, these fuses together and forms conjoint epiphysis, that is around 5 years of age. And the age of fusion, if you can, I don't know about the Ackermann process, but here it is telling that the conjoint epiphysis fuses with the shaft by 18 to 19 years of age, and Ackermann process 17 to 18 years of age, whatever. So yeah, that thing is there. Okay, now if you might have doubt ki, like if you have studied this, why all the bones are forming randomly, fusing randomly before birth only, why not all the bones get ossified, or why not maybe after just birth, why not within 1 years of age everything gets should be ossified. Okay, these are general doubts you might have. The thing is, see, let's suppose if in the fetus stage, if the baby has all the ossified bones, so do you think the baby can come out easily? No. That is why they have the cartilaginous bones. No, they have the cartilage part of the bone. It is not ossified because the baby, the fetus, has to squeeze through the vaginal canal. So in order to squeeze through the vaginal canal, it has to be flexible. Bones cannot be flexible, cartilage can be flexible. You can just turn around your ears. Okay, so that is the flexibility that cartilage has. Now the next doubt you can have, okay, so I understand that it has to come out, so it does not have any bones. What about after it comes out? Why not within 1 year of age it is not ossifying? That is not ossifying because the baby is growing. Now the baby has to grow, and if something has to grow, it has to be little flexible. If it is already stiff, the baby cannot grow. And if you have doubt why the random ossification, like random bone is ossifying at random age or random timeline, that's because the first bones to get ossified in the body is all the weight bearing bones, like the long bones, the leg bones, the limb bones, okay, which has a pivotal role in weight bearing. But those bones which does not have so much role in weight bearing, major weight bearing, like the clavicle or the sternum, so all these bones ossify till the last. Okay, so there is no urgency in ossifying these bones. So body takes aram se time. Okay, it's fine because these are not the weight bearing bones, they are just the weight transmission or the force transmission bones. But all the long bones, the limb bones, okay, the leg bones, the hand bones, all these are weight bearing bones. So all the weight bearing bones, they ossify, try to ossify first. So at the end, what I am trying to say is that the timing of ossification is not random. Okay, if you're thinking it is random, it is not random, but it follows a highly regulated process, and this highly regulated process is driven by genetics and the physiological need. So as there is functional need or the physiological need, so if the body understand okay, this person now has to start walking, he has to start running, at that point the body ossifies that part of the bone which is important in running for the baby, right, for catching things, holding things, lifting things. For all these long bones are necessary. So the humerus, all the long bones, radius and all this, they also start to ossify. So this is how the long bones or the weight bearing bones, they ossify first, and which are not essential in weight bearing, they ossify at last. Even the carpal bones, if you talk about the carpal bones, as the baby grows and it learns to catch things, hold things, so the hand bones, they ossify in sequence to match what? To match the fine motor skills like gripping, writing, as I told. Okay, so I hope I made some sense. And as I told, this might not be proper video for someone who is looking for in-depth of all the things, because myself I am also confused how all this is a part where you rely on experience. The more you see x-rays, the more you experience day to day by watching x-rays and all, that will give you an upper edge. And I have hardly seen any x-rays, just because I have exam next week, forensic practicals, and I have to study all these things. So I have taken up this video. Hopefully it was understandable.